blah, 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 blah. There we go. Come some more people. So I would hope it's obvious that I'm not going to discuss any questions from the quiz because it's still going on. In fact, I got to make sure somebody's taking the quiz right now. I can see somebody taking the quiz right now. If they log in, I'm going to have to kick them. That is going to be highly questionable behavior. So I got to watch for this person. All right. Anybody have any questions from homework stuff or general questions or anything? Are you guys doing okay with the homework? It does get a little bit weird in certain places. Chapter 9's hard, yes. Chapter 9 is hard. So we could do this. I've got some, I figured there was enough problems. Thanks, Doug. Let's try this out. Let me see. If I look in the book, let's go to the review section. Can you be, sure, of course. Let's do that. That sounds like a beautiful idea. Yeah, I didn't mean to do that, so let's do that. That last section, I told you yesterday that I was going to go through it semi-quickly because it just was, some other formulas you could put together. And I try to remind you guys, in almost every section of chapter 9, there's proving identities. There are so many identities because there's so many ways to put these trig functions together and then simplify them. And every time you do that, it's a new identity. So I try to explain to you that there are certain ones of those that are very base identities we have to memorize. And then there were some that were sort of okay, but we didn't have to memorize. And then there's the infinite almost amount of all the other ones out there that we can create whenever we need them. So let's do this. Let's kind of review what we've done so far. And then I want to go to the review section in the book maybe and do some trig identity verification together. And let me see if anybody has anything more specific about what's making chapter 9 hard for you. We can focus on that. I live off of questions. I don't know if you guys have noticed that. I'm a question vampire. I want to eat the questions. All right. I know. Give me a minute. Man, I gotta clean this thing. Poor little thing. All right. So let me see. Did I do this? Let me do this before I forget. It's all about me. All right. So let's start with the real basics. Straighten my room out. There we go. So we got these bad boys here. All right. Holy crap, I forgot. Give me a second. I was messing around with this. Hold on. Is that backwards for you guys? It must be, right?
Yeah.
I was messing around with my alternate dimension. Let me come back to your dimension. There we go. Okay.
I thought you were super talented and able to write backwards. It was pretty cool.
I wish, man. You ever seen those? You write on the glass so you can face the people and write backwards. There's no way. No way. I am not anywhere near that talented. And then to develop, there's 3 of these total, right? These Pythagorean identities. If I divide by cosine squared, I get tan squared plus 1 equals secant squared. And then I get the one that involves the co stuff. If I divide by sine squared, I get 1 plus cotangent squared equals cosecant squared. All right. You guys with me at the moment? These are the absolute most basic identities that you couldn't do much else without. All right. Let me see. Now I got to go through time with this. We've got the ones. I mean, we've got these little dudes. You got to know this is really related to what are the symmetries, right? So does somebody remember what sine of negative theta is?
Negative sine theta.
Good, because sine is odd, cosine is even. I like it. And then that means tangent would be odd.
Can you explain that further, please? Why sine would be odd and cosine is even?
Well, you can tell from the graphs now that we got the graphs developed, right? That definitely looks more cubish. So if I input a positive angle and then I input a negative angle, the outputs are directly negative of each other. That's what that means. Isn't that what that says? If I input the negative of an angle, it's the opposite of what the original angle output would have been.
Okay, that makes sense. Thank you.
I like it. And that's the whole idea of odd symmetry. So to be honest, you can actually learn this shit without using the word odd at all, but that's officially called odd symmetry. And then of course, cosine does this little dude. I love the little octopus dude. And then if I put a negative versus a positive, it's the same thing. So it doesn't care that it's negative. And I also gave you this way to look at it. If I put a positive angle and a negative angle, the cosine piece is the same. The sine piece is the negative of that because it's the y piece. Maybe that's even a better way to look at it. Does that make sense? All right, I'll take that as yes. Okay. And then the reciprocal stuff is just the same, right? Cosecant would follow this, secant would follow that, cotangent would follow this. All right, so you got those.
Yeah.
Then we've got, for example, who remembers what? What's up? Oh, let me see. There we go. Thank you. Who remembers what this is? Sine of 2 theta. Anybody? Nobody? So I don't know if you guys remember. There's a guy who looked a lot like me that was me that was telling you, you've got to memorize this stuff. You have to memorize, especially the ones I've done so far. But everything above that black line on the Trig sheet, the one on Canvas that says Trig Laws, you need to memorize, right? That's all there's to it, because you have to memorize them because other things we do build off of them, right? So you have to memorize these. What sucks about cosine 2 theta? How many ways is there to write that?
Isn't there 2 ways to write it? No, there's 3. I'm sorry.
That's right.
So it's cosine squared theta minus sine squared theta. And then I forgot the other 2.
Oh yeah, so now watch. If you remember that one, that's the one I remember. And then I build the other 2.
Okay.
Because I always forget, trust me. I don't know if you guys, you probably didn't realize this. The last time I wrote this on the board, I took like a couple of seconds before I wrote the next one. Because here's what I'm doing in my head. Cosine squared. So sine squared plus cosine squared is 1. So 1 minus, so cosine squared would be 1 minus sine squared. So 1 minus sine squared is 1 minus 2 sine squared. All right, I don't know if you followed me on that. I have never memorized that. I will never, I don't know. At this point in my life, if I haven't done it yet, I'm probably not going to do it. Memorization, by the way. I think I'm out of room. I'm going to start forgetting things. So the other way would just be the other way. It would be 2 cosine squared theta minus 1. All of those are equivalent. Now, I kind of skipped something. I'm not on purpose, but where did those come from? How did we prove these? We proved them from these formulas. Let's see, what can I do? Sure, I could use that, but let's use alpha and beta. Right? Who remembers what sine of alpha plus beta is versus cosine of alpha plus beta?
Isn't it sine alpha times cosine beta plus sine beta times cosine alpha?
Kick ass, right? Sine is the nice guy. Let's take turns. Let's keep the sine the same. Woo. And I love this. Cosine's an asshole. 3 ways. What the shit? Sine is like, I am this, and cosine like, I am all of these. God damn cosine. I just love that idea that cosine's an asshole. Sorry. That's the what did you learn in pre-calculus, honey? Cosine's an asshole. That's all I learned. What about this guy? So he's an asshole. So how's that one go?
Cosine
I keep
alpha.
shouting, and I think my neighbor kids are out there. Asshole shit. No, my windows are closed. Don't worry. Sorry. Cosine
Alpha times
alpha.
beta minus sine alpha times sine beta.
I like it. He's an asshole. Me first. Plus, I'll make it a minus. Now you go sine. I'm done. I like it. So if this was a minus, this would be a minus. If this was a minus, this would be a plus. So there's 4 equations for the price of 2. And then, so remember, we got this equation, we got this identity by making these both theta. Sine theta, cosine theta, plus sine theta, cosine theta is 2 sine theta, cosine theta. These come from these. So you can make an argument that you don't really need to memorize these. You could just memorize these and then build these when you need them. But you don't want to do that too much. You want to have some more building blocks for other things. How are we doing out there so far? Okay. Then we got the kind of newer ones. What about the half angle formulas? Does anybody remember what this is? Let me get it started. Think about minus.
Sine is that 1 minus cosine theta divided by 2?
Good. And this will be 1 plus cosine theta.
Yeah, because he's an asshole.
Because he's an asshole. He gets the plus sign. God damn you, cosine. And believe it or not, I'm walking on air. No, believe it or not, these equations come from these equations. Right? If I make this theta over 2, this becomes theta. Add 1, divide by 2, take the square root. I mean, that's where it comes from. That's where that comes from. So there are some ways to reduce the number of things you memorize, as long as you're okay with building others as you need them. So that's up to you, whatever feels better on your end to do. All right, let me get it out of the way for a minute. I'm not going to rederive these. We have deriven all of these. We have every single one of these. These were the exciting ones, at least for me. I love these because you got that big, remember the triangle that had the other triangle and there's a big ass triangle. I really do love that. But nobody apparently loves it because nobody's requested that image to be, and I don't blame you. I understand. I just love that shit. It's so much better than the proof the book gives, I think. Let me see. Did I forget anybody? Was there anything else we're supposed to know? Let's take a look at that green sheet. Do. Where are you, green sheet? Let me see. Let me take a look here real quick. Hold on, everybody. Just hang on. Okay, good. Okay, good. I just need to make sure if somebody was here or not. Here we go. Green sheet. So let me just show you where this is in case you're not aware. So if you go to Canvas and you come down to Unit 9 and you look here, Trig Laws, which to memorize. There we go. So you got to memorize all the ones up here. I didn't put these guys, but this kind of shows you the neat thing about this piece is it shows you why we've named them the way we have. Sine is shifted cosine, or cosine shifted sine, however you want to look at it. Secant is shifted cosecant. Cotangent is shifted tangent. So that's why the co-pairs are the way they are. When you first learn about it, it's like, why? It doesn't make any sense. Why is that secant and that one's cosecant? What the shit? Well, this is why they are. Okay, maybe. Let me see. And then this here, you do have to know this. This isn't a function or a formula, but you do have to know this trig inverse stuff here, right? The range and the domain. And it looks like I did not forget anything. We just haven't done these yet. These are coming someday. Law of sines and law of cosines. I love the law of tangents. Look at that craziness. We talked about these last time. And I'm really sorry if I came off as being a little disinterested in them. Just deal with that as you will. But I'm not going to pretend. So I want you to understand, when I'm excited, I'm really excited. So I'm not pretending. I'm not going to pretend to be excited about these. And there's some other random stuff down here. So everything below the black line, you don't have to memorize. If you want to memorize them, go ahead. It's fantastic. Everything up here, you need to know. You need to memorize. Is there any other specific questions about any of that out there? Okay. So again, it's however you memorize things. I try to find either things like cosine's an asshole that's kind of overarching. To be honest, I can't even remember how I did these specifically, got them in my head, but I did look for things like cosine's an asshole. I can't even remember the first time I came up with that. All right, so no questions? We're all good? Okay. So do you guys want to try out a few identity verification stuff together? Okay, all right. Let's take a look here. So I'm going to pull up the book's review exercises just to take some right out of the book, unless you have anything specific. That is hilarious. 2 people just private chatted me the same thing. It says, yes, please. Okay. Have you guys met me? Did you know that I answer questions? Did you? I don't know if you knew that. I never want you to feel like, man, why wouldn't he just do this? How do I make him do this? You just ask. You just ask.
From the dumb student perspective, it's mostly just, we're just lost and we don't know what to ask or how to ask it. So we're like, do you want me to do this? And we're like, yes, just do it. Because whether or not we know how to do it, we probably don't know how to do it.
I don't know. Don't ever let me make somebody feel dumb for asking a question, right? If you ever feel like I've done that, you got to call me out on that, because every question I will answer. I will sometimes say something like, we just did that problem, or, if that's true. But please, dear God, ask the question. It is my job to answer it and to deal with it in a professional manner. Let's try this one. Let's try one that's not an identity proof, but it's using an identity. Let's do a couple of these, and then we'll get into identity proofs. So what if I wanted to do, I want to figure out what this is. So I like this one because it's kind of going backwards from where it used to, but what is this related to? What identity?
Sine times alpha plus beta.
Oh.
Beta minus beta.
Okay, but be really, really careful. I'm going to pick on you a little bit. This is not sine times. This is sine of. So yeah, this would be related to, that's a minus here, right? So how do I know it's sine? Because it's sine, cosine, it's taken turns. How do I know there's a minus? Because sine is nice. It keeps the sign the same, S-I-G-N. So it'll be sine of 70 minus 25. Is that cool? Degrees.
I feel like at this point, that was such a long time ago.
Oh, okay. I don't know anymore. I have no correct concept of time anymore. What is time? Okay. And of course, what's that? That's sine of
45.
45, which is
Rad 2 over 2.
rad 2 over 2. Root 2 over 2. I like it. All right. So that's, like a concrete application of the identity stuff, right? Okay. So let's see. What did I want to point out here? I want to point out something interesting. So here's problem 1. What's different about this problem here? You could do it, Jeff. What do you got, buddy? There's a difference here. What is it? All right. Does anyone see how it's different?
Would alpha be 25 minus 70?
Yes. So it is specific that it's got to be this angle minus this angle. And what is sine of negative 45 degrees?
Negative rad 2.
Yes. And how does that relate? Now watch, I really want you guys to see this. So if I did the opposite of this, wouldn't that equal the opposite of this? Which would be the opposite of this, which would be negative rad 2 over 2? Which that's what that is. Okay, so that it kind of comes back together. It kind of comes back on itself. It's nice. All right, maybe. Let's see. Yeah, let's look at this. Let's see. Wait a minute. Let me find a decent one. All right, let's try this. So everybody got that? That's pretty straightforward, I think. I hope. How about this? Let's all sit and stare at this for a minute. Where'd it go? Jiminy Jeebus. So now we're going to do a proving an identity problem. Oh shit, I was about to copy from the wrong problem. Oh, that would have driven us all insane. Yeah, be really careful. You really want to double check and make sure that this isn't one problem and this is from the next problem down. You will go insane. So I'm gonna let you guys, don't say anything yet if you see something. I just want to let you stare at it for a minute. And then I just want to know what side you want to start with. I think there's a pretty obvious side to start with, but let's find out. Now, you know, you can have your, there is a way to do this with, probably the most direct way to do this is with the double angle formula for tangent. So I told you that I would certainly have these available for you. I would put them on the quiz if I have anything that this would be necessary for. So this is one you don't have to memorize. So I am sort of giving this shit away, damn it. But oh well. Can anybody see why that's going to be useful for this problem? This might not be the only way to do this problem, but
Cotangent, right?
I like it. So what are you looking at? You're looking at this here?
Yeah.
Because yeah, one of the first things I could do with this is cosine of something over sine of something is, like you said, cotangent of that thing. And cotangent of twice the angle, we did this yesterday, is just the reciprocal, because cotangent is the reciprocal of tangent. So what's this going to be? 2 times, what goes here?
1 minus tangent squared beta.
Yeah, be careful. You got the x here now, but you got it. Over 2 tangent. So I see this dies, and then I'm there. You guys see I'm there? What's 1 over tangent?
Cotangent.
And what's tangent squared divided by tangent? Tangent. Check. I like it. So do not freak out. Everything I say you don't have to memorize. If it's necessary for the quiz, it will be sitting on the quiz. The other ones will not. The ones you have to memorize. Let me see. Let me see if I can find a more interesting one. Dadgummit, they really don't give many, do they? You're crazy. Well, let's take a look at this one. This one looks freaky. So pretty cool with that. And then we can do some out of the homework sections, some that I didn't assign for homework. Let's see. Here, you guys try this one. I'll find some more interesting ones. And if you have any that specific ones you're working on in the homework, just let me know. I can do something like it, or I can do it. I guess I'll keep this going with the parentheses. So this is cotangent x times cosine of 2x equals that. So try to do anything. Part of learning how to prove identities is to make a bunch of mistakes about how to prove identities, right? The first step is, let's see if anybody gets this quote. The first step to being really good at something is really being bad at that thing. I think I roughly got the idea. It's been too long since I watched that episode. Was it? I think it's the first step of being really good at something is sucking at something or something like that. Let me see. Am I in the way? No. Okay. All right, we'll do a few of these, I think. Yeah, why not? What really sucks when you have to prove identities that involves this guy again is there's 3 options for this guy. And normally one of them is the best one. So who's got somewhere they think is a good way to start this? I can tell you a general thing. Do all my angles agree? And I don't mean on,
Yes.
okay, good, thank you. I was about to say, I don't mean on who to vote for president. I just mean, are they all the same angle? No. So if you're not sure what to do, that's a great first step. If your angles aren't all X, some of them are 2X or some of them are something else, then you want to try to see if you can make them all the same. That's not a bad idea, especially if you don't know what else to do. So let me make them all a single X. So what do I do with this? Well, we don't know yet. Let's leave it blank, right? Because there's 3 options for this guy. So let's work on that side a little bit. And maybe I can see what I should pick. Does everybody see that? So again, cosine is being regular self there. So what would this be? There's a negative sign on it. So let me write this as, well, it doesn't matter, Jeff. So it'll be negative. And what sine of 2x?
2 sine theta cosine. Or
2
cosine.
sine x cosine x, I like it. Plus cotangent x. Now, I would do something maybe a little strange, but let me just leave myself out for a minute. Does anyone have a suggestion on what to do from here? There are no immediately bad ideas. Unless it's something illegal.
You're trying to
this
get
is-
rid of sine, right? So maybe dividing by sine.
So why are you saying get rid of sine? And be careful. What do you mean divide by sine?
Divide 2 sine x cosine x plus cotangent x by sine so that you can get rid of that sine on one side.
The problem is I can't do something to both sides because the equality is something I'm trying to prove. So I can't
No,
use...
not left or right of the equality. I'm talking both cotangent and sine and cosine on the right side of the equality.
I'm with you. But so how do you really, you got to balance it then. If you want to divide by sine, you have to also multiply by sine at the same time.
Gotcha.
Well, isn't cotangent cosine over sine?
Okay. So
Or
let's
is
see
it
if that
actually
goes
that
somewhere.
backwards? Yeah.
Let's see if that goes somewhere. I mean, so I don't know if part of the problem is that you haven't seen what we're doing right now. Maybe that's part of it because we've done some of these before and I've tried to tell you that part of the process is to try something and have it go nowhere. That is part of the process. And I don't know, you guys maybe don't trust me. You don't believe me. You heard me and you believe me, but you can't live it as you're doing it. You're like, I'm doing this wrong because I tried something that didn't go anywhere. Screw all this shit. But that is a part of how this works. So let's try it. I love it. You notice that this is cosine over sine, right? And it's not a bad idea to break everything into cosine and sine if you're not sure what to do. Is that going to get me anywhere? Does it look like it's going to go anywhere? Anybody?
Not really.
All right, let me give you my suggestion. Let me tell you what I was thinking about trying to do. And let me see if you guys can see why I would think to do this. Actually, let's stop for a second. Before I do my weird shit, does it seem like there's any good thing to put in here for cosine of 2x? So what do I have as an option? Let me write them all down here. I got cosine, cosine squared x minus sine squared x. I've got, now I got to remember, see? 1 minus 2 sine squared x. And I got 2 cosine squared x minus 1. And let me do this for us. Look, does everybody see? I really, stay with me. We are playing around with this shit. This is what I was trying to tell you. This is what we have to expect to be a part of the process. Isn't cotangent, so that's cosine over sine. And let's rewrite these 3 options. Believe me, I've done this a lot because this guy, you never know what's going to be good until you kind of look at it, all the options. It's pretty cool with what's happening right here. Those are all equivalent things, and I just don't know if any of them are going to be better than the other ones. Do you see, does anyone notice how there's a minus 2 and there's a minus 2 right there? Do you guys see that? All right, so right now I want to say something again. I can understand not liking this process. I can understand that. That happens sometimes. And I can understand that me loving this doesn't help. All right. But I want you to understand why I'm trying what I'm trying. You guys with me? So understanding is more important than liking, although the liking piece would be awesome. I'm not sure what that, somebody just private chatted me a suggestion. It sounds sort of like what was being offered before. But now, do you guys see why I'm thinking this might be a decent thing to try? In fact, I don't know if you guys see that that's going to be the answer.
But then what do you do with the fact that it's sine squared?
Let's find out. You ready? Let's find out together. What was it that drew me to this? Was there's a -2 stuff and there's a -2 right there, right? All right, so let's try that one. And if it doesn't work, guess what I'll do? I'll go back and try another one, or I'll work on that side some more. Do you guys, I mean, that is it. That is part of the process. You're not used to that. You're used to algebra where you have one line and then you have the next line and then you have the next line and then x is 2. Yay. You're not used to going, oh, shit, let me go back up here. You're not used to that. At least, you know, not as being part of the process. Watch what happens. Cosine x times sine over sine x is cosine x over sine x. -2 sine squared times cosine x over sine x. And what happens? What happens?
1 sine x goes away. Like it
So don't I get -2 sine x cosine x plus cosine x over sine x? I'm done, aren't I? All right, so again, we have done quite a decent amount of these identities together, and I keep trying to point out to you and again, the whole point is seeing what the flexibility is. What's the flexibility? What am I allowed to do? And what am I looking for? So you can't generalize this shit. I saw a -2 and I saw a -2, but it's that other idea of, I know I want this to look like this. So when I see something that kind of matches, I'm going to go that way because I know they're supposed to equal each other in the end. You always have that. You always have a built-in hint. One side's got to become the other side. It has to. Okay. Now I'm curious if my way would have been decent. You guys anybody want to see my way? Or are we good with this working? All right, let's move on. I like it. All right. Let me see. Oh shit. I lost my place here. Give me a minute. Here, let's take a step back. Let's try some more basic ones. Yeah, let's try that. I like it. I'm going to take this away. Later I'll try my way myself. I'm curious what it looks like. Here we go. What about this here? You guys still see that marker? No? Yes? Okay. All right, so the instructions here are just simplified. You notice how there's no equal signs. So this is not a proven identity. This is just simplify as much as you can.
Can you pick another letter besides T?
Yes, let me
Thank you.
do that. I can always, they're dummy variables, right? Yeah, I didn't make that T correct, did I? All right, I'm with you. How about S? When we need to use S? No, all right, I'll use X. All right. Let's see what else we got here. Oh, that's kind of funny. I like that one. All right, who's made some headway on this? What do you notice here? That's nice.
Those reduce to 3 sine squared x.
I like it because cosecant. Holy shit, John. All right. Cosecant is 1 over sine. So that's going to cancel the sine squared. I like it. Then we have plus cosine squared. And then we have what goes on over here. What's cosine and negative x?
It's just cosine of
Just
x.
negative cosine x.
Good. No, it's
Just
cosine of x.
Cosine X.
Sorry.
So
Yeah,
then it
it's
comes,
just-
so
I
it
like it.
becomes 3 cosine X, right?
well,
Because
no,
then,
squared
no?
x.
Okay.
right here. So it becomes 2 cosine squared x, right?
Oh, I was reading that wrong.
That's right. So already with me so far?
Yeah.
Okay, I like it. I like it. And of course here, so here I got 3 sine squared plus 3 cosine squared. I love this. What is that?
1, is it 1 or 3?
No. You can pull a 3 out, right? But I want you to get to the point where you don't have to do that step.
What's sine squared plus cosine squared?
Just 1.
That's 1. So this is 3. So watch. So that's done. I've simplified that as much as I can. It's 3. I can't go any further. So we know 1 sine squared plus 1 cosine squared is 1. So what is 78 sine squared plus 78 cosine squared?
78.
70 freaking 8. Of course it is, right? I like it. Some of you guys are like, yeah, good job, Jeff. All right, be quiet. So what about this? What about this? All you people thinking that. What is 4 sine squared plus 5 cosine squared? It's 4 plus cosine squared. Do you guys see that?
Oh, because there's an extra cosine squared. Okay. That makes
Yeah.
sense.
I got 4 sine squares and I got 4 cosine squares. That makes 4. And I have an extra cosine squared. Whoop-de-doo. So yeah, you're right if you say you can't put them together. These aren't the same, but that just means I have extra of one of them. All right. That's a whole little side trail to go down. But this is kind of key. If you see, so 2 things. If these are the same, and of course the angles have to fundamentally be the same for the identity to work, the answer is whatever this is. Because of this. Okay, I like it. I like it. What was the other one I liked? Oh yeah, this is really funkadelic. Let's do this one. Let's see. What time is it? All right. All right. Trying to give people a chance to yell at me if they're not ready. Oh, well, nobody did. Look at this bad boy. Where'd you go? There you are. Yeah. All right. By the way, these we're doing right now are coming out of section 9.1. Why in this problem, just to circumvent anybody trying to do this? I told you when you have fractions, you might want to try to get like denominators and put them together. Why does that not apply here? What are the denominators in this problem? What's special about the denominators?
They're the,
They're-
sorry, I forget the word for them. Not inverse.
Reciprocal. I love it.
Reciprocal, yeah.
Yeah. So they're already reciprocal functions. They don't want to be down there, right? They want to flip and be the other dude. They want to go back from the upside down. I like it. So that's something to notice. So there's no real fractions here.
Oh yeah, that was nice. I like that one. All right, so let's see here. So the easiest thing in this is to just make that what?
Cosine squared theta.
I like it. And of course, that's easy. And then what can you do with this guy? This guy will come up and become,
Sine.
I like it, sine squared. And what is 1 plus tangent squared?
It's sec squared theta, or secant.
I like it. Sec squared, why not? We can do some biology. And then, what's nice about, all right, I bet you this is the video my dean chooses to watch to evaluate me. So what's nice about sex, or this guy, especially in relation to this guy, this be sine squared over
Cosine squared.
cosine. And what's that?
It's just tangent.
Tangent squared. And there's my plus 1. And again, what's tangent squared plus 1? I forgot my freaking angle. There we go, Jeff. Sec squared is the answer. Okay. All right, and again, not every single identity problem we do is going to necessarily have like a generalization you can make, but most of them will actually. So if I see these inverse reciprocal functions, then maybe the first thing I do is flip them back over. And then I step back and I see what's going on. We also have this idea of changing everything into sine and cosine. And that sometimes is a last resort, but sometimes it's the only thing you can do to get somewhere. All right, all right. What about this dude? I like this dude a lot. All right, I'm gonna erase all this sexy stuff up here. God, that's too awesome. Dean watches it. It's been nice knowing you guys. All right. So let's see. Cosine A plus B. So prove this. No, that tab, Jeff. There you go, buddy. There it is. Tanatamb. Is that me? Jeez. You mute that tab. Be quiet. Damn. I got a lot of emails. Yeah, whatever. All right. Catch up on those later. This one could possibly, I could see it having people turn around, but there's a very simple place to start on this one. There's really only one thing in this whole thing that you have an identity for, right? Which piece is that?
The numerator and direction.
Yes, I only have an identity directly for this guy. Shiboo. So what is that identity? Cosine.
Cosine A times cosine B minus sine A times sine B.
And do you guys see now you're done basically? Right? Because that divided by itself is 1. Sine O sine is
tangent, and sine B over cosine B is another tangent, which is that check. I like it. I like it a lot. All right. Is anybody feeling any better at all about these things? All right. Okay, so get in there and you can ask me specific questions. I might do some of them directly with you, and I might do some that are sort of like the one you're doing, you know, just so I leave you enough stuff to do on your own. Well, I like that one. That one's neat. Anyway, we're not going to do more of this. I want to do just a couple of problems that will lead us into the direction we're about to go in, and then we'll call it a night. Okay. I'm going to take this away. This was a nice one to end on. It was pretty nice. You were very nice. So let me ask you your thoughts on this. If I just say solve, what you got, Jeff? Let's do cosine theta equals 1/2. If I just say solve that, let's see what you get. Go ahead. What do you get? And then I'll tell you. Well, we'll see. Maybe you'll be right. So there are two, what I would call base answers. Can somebody give me one of them? So solving this tells me I want to solve for the variable theta. Can somebody tell me one angle that this is true for?
pi/3.
Yeah, pi/3. I like it. It's got to be far away from the x-axis, so cosine gets scared and becomes small. So it's 6 degrees, pi/3. But where else? Somebody else tell me what's another angle. So let me draw it for us. So far I got pi/3. Gives me x piece of 1/2. See how useful the picture is. What other thing gives me an x piece of 1/2?
Negative.
What quadrant would it be? Say again, sorry, Willie.
Negative pi/3.
All right, cool. I like it. Negative pi/3. What's another way to say negative pi/3 if I go this way? So you can think about it. This really is 2 pi. So what's 2 pi minus pi/3? That'd be 6 pi/3 minus, yeah, 5 pi/3. Now, to be honest, there's nothing really wrong with what you said there, Willie, but there will be some problems that will tell you to find all the answers between 0 and 2 pi, for example. So you won't be allowed to have negative answers. But the way I put this, how many answers will there be? I'm not done yet. Why am I not done yet? I am so not done yet.
You can go around and around and around and around.
Holy shit, right? So I can start at this answer and I can add 2 pi around to it, right? So if I started this answer and I add 6 pi/3, I get 7 pi/3. And then I could do that again. And then I could even go backwards. I could start here and go backwards 2 pi. What the shit? So watch what I can do. I don't know why I put it like that. I've got my base answers. Notice something interesting. What is the period of cosine?
2 pi.
Pi.
2 pi. I love it. We got to be careful, but this is interesting. So what do I keep doing? I'm going to keep going around the circle as many times as I want to, which means I'm going to do this as many times as I want to. There's good old K coming back. Sometimes you see N here also. I have no idea. I use K when I mean it can be negative. N very often is an element of the natural numbers, meaning it's 1, 2, 3. So K would be an integer, kind of, is what it's assumed to be. But if you put an N there, I know what you mean. But so of course, what do? This guy, same idea. I can start at this guy and go around. I can go backwards. That is the complete solution set to this equation. So if the question was said, solve this, give me all the answers between 0 and 2 pi, my answers would have just been these, and I would have stopped. I like it. I like it. So let's try one more, and then we'll call it a night. I want to show you something interesting. Notice, by the way, let me make a point out of this. Let me get rid of my spaghetti here. Here's pi over 3. Here's 5 pi over 3. Is there any way to kind of like go around at a specified interval and pick this up and then pick that up? I have no idea if I really don't know how to say this. Can I add some multiple of the same thing and pick this up and then pick this up and then pick this up? Can I write this in one line? No. Let me just stop anybody who's trying to figure that out. You can't. But watch this. Watch this shit. And I've given myself no room. This is awesome, Jeff. Good planning. What about solving sine theta equals negative rad 2 over 2? I like it. Let me see. Is that going to work the way I want it to? I have trouble thinking. No, it's not. Let's do this. Yeah. Let's do this. Wait. Stop. You can do it, Jeff. Well, that's going to have to be. Well, screw it. That'll be fine. We'll do another one next time. Let's just do this. Tangent, get out of there, you silly person, equals negative 1. Maybe some of you guys can see what I was thinking. Tangent theta equals negative 1. What quadrants would that happen in?
2 and 3.
No. Tangent sine over cosine. So it can only happen where sine and cosine are opposite sides.
So
In 3, they are the same sign. Sorry? Yeah, 2 and 4, yeah. 2 and 4. I like it. So what's this answer? What's this angle here?
Pi over 4.
Not pi over 4 now.
3 pi over 4.
3 pi over 4. And what's this answer here? Start at 2 pi and go back pi over 4. So start at 8 pi over 4, go back pi over 4.
Pi over 4.
7 pi over 4. I like it. Now, I could do this again. This picks up all the answers, but this is kind of dumb. Right? So there's another point I wanted to make, but this is fine for now. Let's make a point about tangent. What's tangent's period?
Pi.
Pi. So if I add pi to this, where do I end up? Don't I end up here? Isn't that exactly linear? Isn't that exactly across from it? Right? So I don't need this shit. I can just say this. And that's the point I was trying to make. Why do I only need one line? Because the distance between this to this is the same as the distance between this to this. That's why I can keep going this multiple of the same thing. This guy, oh shit, wait, oh shit, wait, I can't do that. I can't keep going the same multiple and pick them up. That's why I need 2. Also, it makes sense that this will show up in most of these, not all of them, for tangent, because that's the period of tangent. That kind of makes sense. Yay. Cool. All right, so next time we'll do some more complicated trig equations, but this is the base idea. The answer to the question, solve this with no domain, with nothing given here, is going to involve some kind of infinite adding of stuff, which also means subtraction, because k can be negative. You can go backwards. I like it. All right, I think that's enough. So that's section 9.5. We'll obviously do more of that tomorrow. Let me know if you guys need to hang out. If you have any questions, let me put my head over here in case you're still copying.
Yeah, I have one question.
Yeah.
Just about what you're talking about, how we need to have two different answers, I guess, because you're talking about how you can't hit both at once. How would you properly write out an answer like that?
Like that.
I don't know, just like that?
Yep.
Okay, got it.
I like it.
Thank
Now, of
you.
course, I want you to realize that if you start putting some squares on things and you start doing some other interesting equation type related stuff, you can actually get more answers within, right? And maybe some of them can be picked up and some of them, I don't know if that is making sense to you right now. We did some very basic equations. We're going to have some more complicated equations, some quadratic trigonometric equations. That makes it sound so horrible, and it really isn't, right? And then we can have answers, several base answers between 0 to 2 pi, right? And maybe some of them will have this period that kind of matches for both of them, and some of them aren't in there. So they're going to need their own line for an answer. Does that make a little bit of sense? Okay, I'll take that as a yes. Anybody else? Questions?
Thank you.
You're welcome. All right, I'm out of here.